Good day guys, welcome to my YouTube channel, and now we are going to explain basically today what a multiplexer is and what it does. Now the whole idea, picture this. Have you ever wondered how your computer is able to take different or multiple inputs and then output them as one single output without any interaction or any intermediate breakages? Now this is the whole idea behind it. Now a multiplexer is basically a combinational circuit, so which gives the idea that it combines. So the combinational circuit, which is the multiplexer, selects binary information of different output lines and then direct them into a single output. Now multiplexers are named using the simple format, which is the number of inputs by the output. So if it is inputting 4 inputs, then we name it a 4 by 1 multiplexer. So this is a simple diagram over here. So we have a diagram of a 4 to 1 multiplexer, which means it takes in 4 inputs over here and outputs only 1. And this is a 16 channel input. So moving on, our main focus is going to be on the 4 by 1 multiplexer. So this is a basic construction of a 4 by 1 multi-complexer. So over here you can see that it has input 0. Yes, over here we do see that it has an input 0 and then an input of 1, and then it outputs exactly that. So looking at the truth table here, we get a more clarification that the S represents the input data and the Y represents what it outputs as well. So now this is our main focus. Now we are going to understand how this multiplexer works. Okay, so this is supposed to be a 4 by 1 over here. So yeah, quick correction over there. Now the multiplexer, we are going to explain the multiplexer with this particular diagram step by step. So let's look at this way. The S0 and then the S1 represent the inputted data. The S0 and then the X1 represent the input data. Now the circuit uses AND and OR gate. So here are the AND gates and here are the OR gates. The select lines are connected to this AND gate. So over here the I1, I2, I3 represent the select line. So these are connected to the AND gate along with the data input from here. So these are the select lines and then these are the data inputs. So the outputs of the AND gate are fed into this OR gate. So after this input is being taken, it is being fed into this OR gate. Now I'll have to believe that we all have basic knowledge about AND and then OR gate and how their operation works. So after this information is being fed into the AND gate, it is being outputted over here and then fed into the OR gate over here. Now the select line controls which AND gate is active, allowing only one data input passing through. So here is the catch over here. Now for example, we have an S0 input as 0 and then we have an S1 input as also, let's take it as 0 because they are all not over here. So let's take it as the S0 input is 0 and then the S1 input is 0. So when this happens, the I0 line is selected. This is because both inputs are 0. So basically the line that will be selected will be a 0 gate. So this will be a selected line when this input is 0 and then here is also 0. Now let's look at it over here. When this input is also 0, still 0, and then this input becomes 1, then the selected output will be 1, which is this I1. So let's look at it from this dimension. So when we look at this carefully, we see that this line is highlighted deeper. because it is assumed over here that the S input is 0, and then the S not input is 0, and then the S1 input is also 0. So the I2, so before we can get an I1 input line to be selected, it means the inputted data for S1 should be 0, and then the S not should be 1. So which basically means that the input line that will be selected will be 1. Now for the input line, which is I2, to be selected, it means that this input data must be 0, and then this one must be 1, and then this one must be 0. And then for the input 3 to be selected, it means this must be 1, this input must be 1, and then this input must also be 1. So the final output of the OR gate will be determined after it is being passed through the various AND gates. Now this is where the catch is. So after it is being passed through this AND gate, this AND gate, this AND gate, and this AND gate, the input signal will be determined on which one is selected, depending on the inputted S value, S0 value, and the S1 value. So over here we assume, or we take it that the S0 value is 0, and then the S1 value is also 0. So which basically means that since they are both 0, from what I previously said, then it means that the output must also be 0. Okay, so that is it. So if this inputted data is 0, here is also 0, and you pass it through an AND gate, it's basically 0. So over here the selected data will be, the selected line, will be the I0. So when we pass this I0 through the AND gate, and then it's being fed to the OR gate alongside the other unselected lines, we realize that the OR gate reads the input as Y. So we get our input over our output, as 1. So let me take a quick recap. In summary, the 4-to-1 multiplexer acts as a digital switch, selecting one of the 4 inputs based on the binary code applied to it. So over here, the 4x1 multiplexer selects only one of the lines over here, and then uses that as and output it as a single output. So from the definition of multiplexer, we said that the multiplexer is a combinational circuit that selects binary information from one of many inputs. So it selects information from one of many inputs line, and then this information is outputted as a single output. So that is the logic that is being applied here. So all the input lines are being stated over here, but the input from the S value is 0 and then 0. So only this input line is selected, and hence the output will be that input line. So therefore the output value over here will be 0 when it is being fed to the OR gate. So this is basically how the 4x1 multiplexer works, and then how it outputs data. So the main logic behind this is that for multiplexers, they don't select all the lines. No, they only select one of the many lines and then output only that line as a single output. So this is basically how the multiplexers works, and then how they output data. Thank you for your time, and then see you guys next time.